Okay, here we are, finally to the end. Last lesson in the Purple Algebra book, lesson 11.7, solving rational equations. So what is a rational equation? Well, it's an equation that contains rational expressions. Remember that rational expressions have polynomials in the numerator and the denominator. One way to solve rational equations is to use the cross product property. We did this when we dealt with proportions. So this was one method for solving a proportion. When you see what a rational equation looks like, you will see that it very closely resembles a proportion with two rational expressions equal to each other, which are just basically ratios of polynomials. Okay, so you can use this method to solve each side of a rational equation when it consists of one rational expression. So this is what they look like. So here we go. The cross product property states that when you have two ratios equal to each other, their cross products are also equal. So you multiply here and here. So we have 5 times x minus, x minus 4 equal to 4 times the expression x plus 4. All right. First step then after this would be to distribute both sides. Okay. So 5x minus 20 would be equal to 4x plus 16. Variables on both sides. Solve it the way you would solve it. So we will use inverse operations. We want to collect variable terms to one side, constants to the other. In this case, I could add 20 to both sides. Right, that gets rid of this right here. The next thing would be to subtract 4x because the variable term has to get moved. So I'm subtracting 4x to both sides. That gets rid of this variable term on the right. So 5 minus 4 is x, and 16 plus 20 is 36. Now, an important step is that we want to make sure that it's not an erroneous solution, meaning that it doesn't somehow not make it true. So we always want to go back and solve and check our work. So you just substitute in 36 for x. So when you have 5 over 36 plus 4 is 40, you will then have that equal to 4 over 36 minus 4, which is 32. And each of these would simplify to 1/8. 1/8 is equal to 1/8, so it does check out. You can use some mental math there to help you make sure that you understand that. For part B, we want to cross multiply. So 5 times 7 is 35. And then we'll have y times the expression y minus 2. And we'll go ahead and distribute the y. So 35 is equal to y squared minus 2y. At this point, we're going to start solving, and we're going to start by subtracting 35 from both sides so that we can get a quadratic equation equal to 0, factor it to find the zeros using the zero product property. So we'll subtract 35 from both sides, and we'll get 0 is equal to y squared minus 2y minus 35. We're looking for factors of negative 35 that will sum to a negative 2. So I'm going to pick a negative 7 and a positive 5. So 0 is equal to y minus 7 times y plus 5. Again, at this step, you could check it through FOIL to make sure that it is equal to the quadratic. We know that because of the zero product property, for 0 to be the product, that one of the factors, either y minus 7 or y plus 5 is equal to 0. So we have either y minus 7 equals 0 or the y plus 5 equals 0. This has to be true because if that's what the zero product property means, that one of the factors is 0 for the product to be 0. So you would add 7 to both sides. So you have y equal to 7, or you subtract 5 from both sides, or you have y equal to negative 5. Now, again, especially in the case with 2 answers, you want to check both answers just in case there is an erroneous solution or one of these that we just can't use because it doesn't make the original problem true. So we would put 5 over 7 for the first one. Y is equal to 7, so we substitute in a 7 for y. And when we take 7 minus 2, we get 5 over 7. So we know that 7 is an actual solution, okay? I'll go ahead and circle the 36 too. All right, then we try the negative 5. 5 over negative 5 would be equal to negative 7 over 7, because when you take negative 5 minus 2, you get a negative 7. So negative 1 equals negative 1. This is also a true solution, so both of them would work, okay? So make sure you have that copied down, because to go to the next slide, I will be clearing this page. We're going to maybe do 3 more examples, and then you have about 6 problems for homework that will be scheduled on the next day. Here we go. So we want to solve this equation using the cross product property. So we would take 2 times x minus 7 and make that equal to 4 times x minus 3. Distribute 2x minus 14 equal to 4x minus 12. All right. Now, variables on both sides. So we want to, either way you do it, doesn't matter. You could subtract the 2, and add the 12, or you could, add the 14 and subtract the 4. I always go with variables to the left. I don't know why. It's just my habit. So I will be adding 14 to both sides and subtracting 4x from both sides. Okay, so this one would cancel, this one would cancel. Then that gives me a negative 2x is equal to 2, so that when I divide by negative 2, I'm going to get a solution of x is equal to negative 1. So this is my solution. Let's see if it's true. 2 over negative 1 minus 3 must be equal to 4 over negative 1 minus 7. So a 2 over a negative 4 has to be equal to 4 over negative 8, and they are both equivalent to a negative 1/2. Again, some of that mental math coming into use. So it's a true statement that x could be equal to negative 1. All right. I will be clearing this out. Let's try another. Cross products. We have 4 times z plus 1, and that would be equal to z times z plus 4. I crossed my z's so they don't look like my 2's. All right, 4z plus 4 is equal to z squared plus 4z. So now we're going to want to, it looks like we're going to have a quadratic, so we're going to want to move everything from the left over to the right, because we'll subtract the 4z, right? It actually will cancel here, and it will cancel here. We want to also subtract the 4, okay, so that it will cancel here, and we will be left with 0 equals. So whenever you're going to have one of these trinomials or polynomials or binomials or difference of 2 squares or whatever you're going to have, when it's got the z squared or any variable squared, you know that it's a quadratic. We're going to have to factor it or solve it in one of the ways that we know how to solve quadratics. But using the 0 property is one of the easiest ways. So z squared minus 4, difference of 2 squares pattern. So 0 is equal to z plus 2 times z minus 2. So that one of these two expressions has to be equal to 0 for the whole product to be equal to 0. So either z plus 2 equals 0 or z minus 2 equals 0. All right, so subtracting 2, so z is equal to negative 2, or z, we would add 2, is equal to 2. All right, now, is one of these erroneous? We won't know until we substitute them in. So 4 divided by, so negative 2 plus 4 is going to be equal to, negative 2 plus 4 is going to be equal to 2. Oops, 2. All right, and then we're going to have negative 2 over negative 2 plus 1, which will be, positive 2. So 4 over 2 is 2, and a negative 2 over a negative 1 is also a positive 2. So the first one checks out. The negative 2 checks out. All right, 4 over the 2 plus 4 has to be equal to 2 over the 2 plus 1. So we'll have 4 over 6, and we'll have 2 over 3, and these are equivalent, okay? So that checks out. So both solutions are good. In fact, I believe all of our examples today, we don't have any erroneous solutions. So just be on the lookout, and that's why it's important to check your solutions. Okay, here we go. Last example. Finally, a short video. All right, cross product property. 4 times z plus... I feel like we just did this one, and we did. Okay. How long would it take Miss Kleinman to figure that out? All right, let's try again. Last example, right? Here we go. All right, 3y times y plus 7. And 4 times 6. So 3y squared when I distribute plus 21y is equal to 24. So it's a quadratic. We'll have to subtract 24 from both sides. We'll get 3y squared plus 21y minus the 24 is equal to 0. Okay. Now we need to do the probably your factor fish. You have a 3, you have a positive 21. A negative 24. Been a while since I've done a factor fish, at least since last week. All right, and they will sum to a positive 21. Remember the outer terms, and then they sum to the middle term. All right, so we'll have a 1 and a 3. That's the easy one. And then we're going to have a negative and a positive. We'll probably, let's go with 3 and 4, and let's try negative 3 and, and positive 8. I guess I saw this 4. I don't even know. All right, I'll slow down. 1 times negative 3 is negative 3. 3 times 8 is a positive 24. 24 plus a negative 3 is a positive 21. So these become the trinomial or the binomial factors of this trinomial when we factor it. So we will have y plus 8, and we will have a 3y minus 3, and those would be equal to 0. And again, if you want to check it, you can, at this step, FOIL it. Oh boy, that's a crazy arrow. FOIL it to make sure that you would get to your trinomial. Okay, so what we have is either the y plus 8 equals 0 or 3y minus 3 equals 0. So we just solve each of these simple equations and get y is equal to a negative 8. Or we add 3, and then we divide by 3, or y is equal to 1. So we either have a 1 or a negative 8. Okay? Important to check your solution. So going back to the original problem, we're going to have 3 times negative 8 for the checking, right? All over 4, and that would be equal to 6 over a negative 8 plus 7. So negative 4 over 4 is equal to 6 over negative 1. And since negative 24 divided by 4 is equal to negative 6, the first solution checks out. Let's try 1. So does 3 over 4, because 3 times 1 is 3, equal to 6 over 8? And yes, it does. So the other solution checks out as well. So you can use some mental math when checking your work. Okay, that should do it for solving some rational equations. If you need help or have any questions, please don't hesitate to reach out. I've given you several options on how to do that. So look forward to hearing from you if you need me.